Hey, and then I'm gonna wait until I see at least one person on camera because currently I see nobody on camera. Oh, there we go. Okay. I don't know why you would think Zoom would show all the people on camera up front. I'm seeing lots of people on camera now. Great, awesome, cool. So, so many people on camera. Great. uh, yeah. So today we're talking about async in JavaScript with React. By that I mean talking to a backend. There's a lot to talk about, and a big part of it, based on how I laid it out, is starting with vanilla JavaScript and just learning step by step, because they build on top of each other, just this idea of what is async in JavaScript, because JavaScript is a deceptively weird programming language, and it has this idea called async, which essentially allows things to happen not in top to bottom order, and that can be strange. So we're going to learn about that, and then we're going to learn about the original method of taming that called callbacks, and then the advancement from that called promises, which is now the basic way that people model this sort of behavior. And then we'll talk a little bit about async await, which is like a modern syntax for that. We'll basically just talk a lot about promises and all of that before we get to useEffect, because we use promises there. But in my opinion, I think you guys would benefit just by seeing it first, and then we could jump into like sort of building up to it. So how does that sound, that we just go into, video store part 2, like my version of it, and we start messing with useEffect because we already have an existing React environment. Okay, well, I like that plan, so let's do it. Okay, so here we are. This is part of week 8, day 3. I just have a Vite project called useEffect example. Not much to it. Right now, I simply have a component app, and I'm trying to render a single component called learn useEffect. And that component is here, and that component does nothing right now. Not much, at least. Cool. And I just wanted to point this out. If you've not seen this before, this is what happens automatically when you comment or uncomment in React. And I wouldn't have come up with this myself, but this is a great way to comment things out in your JSX. Basically, you wrap it in these in the escape sequence braces, and then you comment, and then you comment it out. And VS Code will do this for you with whatever your like command button is, command/. So if you're on Windows, Windows/. If you're on Mac, I think it's called command. It looks you have to know that symbol for yourself. But basically, command/ will comment in and out, and it's smart enough to know what React is versus JavaScript. So that's really useful. But yes, we have this learn useEffect component. Here it is. Let me now run this. We're in useEffect example. We'll try this, but from my experience, this is not going to work because it has this little bug around node modules. So we have to delete that and then install it, and then try that again. Cool. And let's see where we are. Cool. This is indeed the thing I made, but I didn't want to show both of them. So let's just get them side by side here. We'll make this one small for now, but just so we can see it. Cool. So I don't want to show this Poke Viewer stuff yet, but we will build to that. How about this? This looks good to me. Great. So all we're seeing is hello world. We've done really not much with this app right now. So what is useEffect, right? Okay, here we are. We imported useEffect from the main React library, just like we could do useState. Just like if you start typing use, you'll see there's actually a ton of these hooks. I guess not a ton. There's only, so many. It looks like less than 20. But you don't see these so often. They all have specific uses. But like I've never even heard of use layout effect. I don't even know what that might be. Whereas certain ones are the bread and butter, and the two that truly are the bread and butter are use state and use effect. Use state, of course, we covered yesterday, and that allows you to essentially tie a data model to the view and handle changes that are generated from the view in the form of events, update the model, which automatically updates the view. So originally we just had a page basically, and then we upgraded with useEffect to a page that could stay in sync with data. With use state. And what useEffect buys us is, so far everything is just, we grab, maybe we talk to a backend to get the actual HTML or whatever it was. But right now, everything is just running on the client side. But in real world apps, you often want to speak to the server when something happens, or you want to speak to some other API. And the way you do that in React is with useEffect. But before we show any API stuff, let's just show useEffect. So just to see it, let's say I was using state, I would have something already like, we'll say name, set name, right? Equals use state. And it takes an initial value called Ben. And so use state takes an initial value and it returns this tuple name and set name. Name is the current stateful value. Set name is how you update that value. And then I can use it here, and I'm not going to worry about updating it. But yeah, so we understand use state right now. And use state has this like API, right? When I use the word API, I use it very generally. I'm just saying like every function has an API. Its parameters, its input is forms half of the API, and whatever it returns is the other half. And that's all you really ever need to know about, because a good API is a black box. You don't need to know how it works inside. You just need to know what parameters it wants. And as long as you provide those accurately, nicely, it's the API's job to return to you the data it tells you it's going to return to you. And if it's broken, that's not your fault. It's not your fault if someone else wrote bad code on their backend. You as the front-end developer simply need to know this contract we call an API. Okay, so what is the API for useEffect? Well, first we type useEffect. See, not so easy. And then what is useEffect? Well, it is a function. So I'm going to open it up like that, and we're going to see that it's telling us, okay, useEffect takes first something called an effect, which is of type React.effect callback. If you're not used to reading this sort of thing, it's probably worth explaining. Basically, this effect is basically saying this is the name of a variable, and then colon means the type of the variable or the parameter. And I don't personally know what a React.effect callback is, but that's something they invented. And then here we have deps, meaning dependencies, and that also has a type, React.dependency list or undefined, implying it's optional. And that's what this question mark means. This question mark means, compared to this, effect is a required parameter. Dependencies is an optional parameter. And then finally, we see this colon at the end. This colon at the end after the parentheses tells us what useEffect returns. In this case, void, which means it doesn't return anything. It does something. And so what it returns doesn't matter. Cool. So useEffect takes this first parameter called effect callback. That's exactly what it is. Callback meaning a function. So anytime you pass a function to another function, that could technically be called a callback. And what it means is I'm giving you a function and then you execute it later. So we could write it in line. We could also, write something like callback and just here say const callback equals, a function that so actually let's just see this. So I just created a very simple function that when called prints console.log. And then I said useEffect callback. And let me save. And if I open this up, we see it did indeed print hello world. So the most basic, what is useEffect basically? So useEffect at its most basic has nothing to do with talking to a backend, any of that. What useEffect is it's a life cycle hook, which means that a React component goes through certain phases in its life. For instance, there is a phase before it's rendered, and then the component is actually looked at and evaluated, and then it is rendered. And then there's a moment after it's rendered, and then of course it could be re-rendered. So useEffect runs after a render. So what that means is this component over here, this component was seen. It needs to be evaluated. It's evaluated based on this function. It evaluates to this JSX, and of course this JSX references something, and that is a use state. But none of this happens before we actually print something to the screen, and then only after it's printed to the screen does this useEffect get called. So useEffect is called after a render, and if you have a first render, the useEffect will not take effect until afterwards. Why is this useful? Well, we want to render our thing first, but maybe once it's rendered, we might want to do something. And in doing something, we could then, as a result of doing that thing, trigger, let's say, an update to use state. So we can trigger like set name or something. So right now I have this useEffect, and it runs exactly once, running this callback after the first render. But let's say I took out this and I actually said, okay, the callback is going to be for set name Darren. Why not? Okay, so that's going to be the new name, and I'm going to save it. And we're going to reload this, and let's try and like look at it real quick. Did you see it? I wonder if I can slow this down with like throttling. So we're going to try and we're on a real slow G network. Let's see if it makes a difference. No, it's probably just going to take longer to load. Okay, let's wait for it. Wait for it. By the way, this is good to see that the whole point of throttling being built into the web dev console is that for most people in America, they have access to a 4G network at this point. If you live in India, anywhere outside of like the big cities, you are on a slow 3G network at best. And so your website may or may not be accessible to people. Okay, we couldn't really see it. I guess the way to take my word for it, or not take my word for it rather, is let's say this callback didn't run right away. So let's say we had a timeout. We said set timeout, and of course that itself takes a callback. Some code it's going to run after that timer is up. And so this is what it's going to run after that timer is up, and we'll set that timer for 2 seconds. And now let's do this. So we're going to reload the page. It says, hello, Ben. We're going to wait 2 seconds. Hello, Darren. Cool. So you saw that this useEffect does not run until after that first render. So whatever your initial state is, that will be the state. And then afterwards, the useEffect happens. But that useEffect can call something. And if it calls something like set name, that's going to trigger a re-render. So you very often see the two combined, where useEffect will do something, and then in response to doing something, set some state, and then that triggers a re-render. What is that fun sound? All right, cool. That was fun. Okay, so what I'm going to do now is I'm going to take this whole callback. I don't really like doing this way. I'm going to put it in here like this. And let's not do a set timeout. For now, let's just do something. So if you look at the React docs, they don't initially introduce it with they don't initially introduce useEffect with talking to an API. They show you a different kind of effect. So by effect, remember when we were talking about functional programming, we said how anything that is outside of the context of the program is called a side effect. Like if you print something to a console, that's a side effect because you don't know if the console exists or not. Like maybe it works, maybe it doesn't. It's outside of the control of like that particular function. So the effect that React shows you in the docs is doing this. I can say something like, okay, so I have this thing called document, right? Or I guess before we do this, let's show this. Imagine I don't do it this way. Let's say I want to update the document, right? I say document.title. Title will be this part, which says v plus React. So first I'm just going to set it to something. I'll set it to Ben. And you'll see it says Ben up there. That's cool, of course, but what if I wanted to have like a live value of some kind, right? So what if I wanted to like keep updating this in real time? Well, useEffect can help us with that because we're going to say, I mean, this is just to show it off, but we're going to say within useEffect document.title equals, and maybe it's going to be a value. Like maybe we literally, this isn't necessarily a great way to do it, but I'm going to have like a global value that I'm going to call, so it's outside of what React knows about. I'm going to say this is just a counter equal to 0. And then I'll say document.title equals counter, which we'll just turn it into a string. And after that's done, we'll update the counter like this, counter plus plus, and I'll save it. Cool. And we see a 1 here because we only did it once. I'm actually surprised it's a 1. I would think it would be a 0. That is interesting. If I take this out, interesting. Probably because it's outside of React. Okay, but I'm only doing this to show you, like, let's put it back in there. Okay, this useEffect, it runs exactly once. It runs after the first render, and then it's done. That's actually, no, sorry, that is not true. Basically, I'm trying to lead up to teaching you this thing called a dependency list. So here's a dependency list. We're going to give it an empty dependency list. Before we had no dependency list. What does it mean when you give something an empty dependency list? It means it runs exactly once after the first render. So what does that mean? That means that if I were to speak to an API, let's say, or in this case, if I wanted to set the document's title to something, I don't think this, let me just make a use state for this. Const counter set counter equals use state of 0. Okay, and then let's say I said counter there. It's going to print 1, a 0. And let's say I print it and then I update it right after. I say set counter to counter plus 1. Okay, so I'm printing 0 and then I'm setting the counter to plus 1, and that triggers a re-render. But notice this only runs once after the first useEffect. Now I'm going to take this out, save. Look, it's going insane, right? And it's saying maximum update depth exceeded. It's going nuts. Okay, so this is something to know about and be careful with, which is useEffect runs this callback function that we define ourselves. But the second argument is a dependency list. If you don't include that dependency list, it runs on every render or after every render. And that's generally too much. Whatever you're trying to do, let's say you're trying to speak to an API, let's say you're trying to update some value, whatever you're trying to do, you probably don't want to do it every single re-render. So the first thing you could do is give it an empty dependency list. What this means is it's only going to run exactly once after the first render and never again. But that might not be what you want either. So here's what you probably do want. I'm going to put the word counter in here. What this means now is that this useEffect runs every time counter changes. I can see because I'm setting counter here, that's going to be not great. But let's try something like this, right? useEffect, document.title equals counter. This only runs when counter updates. And then over here, down here, I'm going to make a button. And this button is going to say, when you click this button, it is going to set the counter to 1 plus whatever it currently is. So every time we click this button, it will update counter. So look, we have a 1 here, right? Now I'm going to click it, 2, click it, 3, click it, 4. And now notice if I didn't have this in here, take that out, reload, click it, click it, click it. It doesn't matter because even though counter is indeed getting updated, like if we looked here in components, let's make that a little bigger, learn useEffect, we see that indeed whatever state 2 is, which is our counter, has a value of 6. And every time we click it, it is updating. Or it should. Yeah, there we go. 12, 13. It just takes a second. Every time we click it, it updates, but this doesn't know to run anytime after the first time. But of course, if we give it counter, it will know whenever counter changes. And just like with other stuff in React, it only counts it as a change if it's a primitive, or if it's a non-primitive, if it's a brand new thing. So this now will respond. And of course, it's a list, not just a single thing, because maybe I also have something like this, where I say, if name changes, I also want you to re-render. So this is this dependency list is an or. Basically, if counter changes, re-render. If name changes, re-render. And might as well show that. Let's say I have some input. I'll make an input. And I'll say type equals text, and onChange equals a function that when it happens, we set name to event.target.value, which I guess I have to provide here. This is getting too long for me. We'll do that. And then finally, just to keep it in line, we'll say value is equal to name. Great. So maybe I have something like this, and now I have this little dialog here, and if I change it, that changes up there, but it also will be calling that useEffect. So let's say I said document.title equals, some combination of the counter and the name as a string. Now, I don't know why it's highlighting it like that. Okay, now if I do click me, that one updated. If I write Benjamin, it also updates. So basically, useEffect is a way that combined with useState, you can trigger changes to the page in response to some event happening, which right now has been trivial. The event happening is just that we run our useEffect, but usually it involves talking to an API. So let's see that. And also just to show, you can have more than one useEffect. So I'm going to leave this useEffect right here, not even worry about it. It's still going to totally function, but I could have a separate useEffect, which will work the same. It doesn't know about the other useEffect. It takes its own dependency list. I'm going to say this one, let's say, only runs exactly once. And what do we want it to do? Well, let's go to the Poke API. When learning this stuff, it's good to know about a free API that doesn't require much to get started with. Today, we're not going to be talking to a real backend, and that we're not going to be talking to our own backend, but we will be using useEffect to work with APIs, or what they call consumption-only APIs. And those aren't all the same. And basically you're going to be tempted, if I say like, oh, just find a cool API to work with, you're going to be tempted to want to integrate with like a Google service, because that sounds interesting, right? Don't you want to like have your app, like, your app can like, create a new document in Google Docs and put some info into it. What I have found in my experience working at boot camps is that if people try and integrate with like a real API, like Google's Office suite, that could take a solid like week of development time to get working, because they have a lot of security in place and it's a really involved process. And you don't really need to be learning how to work with Google right now. You need to be learning just how do I talk to an API. Cool. So let's explore this API. I see we have this get over here. Okay, so I see what it looks like. So right now, all we want to do is pull from some API. And I just want to see the Pokemon. Why abilities? I just want to see the name of the Pokemon. There's a way to do that. I'm positive. Pokemon species, shapes, habits. Why can't I just look them up by name?
What
was that?
Species.
Say that again.
Species is what you want.
Species. Oh, yeah, I might want species as well. I think what I actually want is just Pokemon. Within the Pokemon drop down, there's something specifically Pokemon, and then I think I can reference them by ID, which I don't know, or name. And then what is Pokemon species? What's an example? I think that's just like
the name of the species is the name of the Pokemon.
Either way, I mean, this is just what learning an API is like. You just have to look through it and search for what you want. But basically, we want to call this API. So first thing we're going to do is I'm going to take the app apart, or stop it, and I'm going to install a new dependency, which if you do -- save when you do that, it will actually put it in package.json. So it's important to remember that. I'm going to type Axios. Okay, and if we look in package.json, we indeed have a new dependency in Axios. So now I can import Axios like that. So now I have access to Axios within my JavaScript. And in this useEffect, what I'm going to say is, my dependency list says run exactly once after the first re-render. So I'll say axios.get. And what am I going to get? I will grab this URL. And let's just say initially, I'm just going to give it a hard-coded URL. And that hard-coded URL is going to be, I would try and spell Pikachu, but I know it's possible to get that wrong. So I'll go with Clefairy because they are right in front of me. Cool. So we're going to get Clefairy, right? And the nature of doing something in Axios, you guys have worked in Axios, so you've probably seen this already. I don't know how familiar you guys are with promises, but I actually would, because I feel a little out of sync. Can anyone tell me what is the class's general understanding of promises? Have we seen this idea yet?
Yeah, we went over it a bit during the URL section when we used async.
Okay, cool. So it won't be totally foreign. And later in this lecture, we will really get into what a promise is and how to work with it. But for right now, promise just means that this axios.get, let me hover over it, it returns something. What does it return? It returns a promise. And again, for reading these sort of documentation things, this is saying it returns a promise. And then those brackets, the triangle brackets mean like subtype. So this is the whole thing it's returning is of type promise, but that promise, just like an array, can be an array of integers. A promise is a promise of something. And I don't really know what an Axios response is, but we're going to see. So the API of a promise is that, axios.get will return a promise. And then a promise is an object that supports certain methods, specifically .then and .catch. .then will run if it was successful, and .catch will run if there is an error of some kind, and .finally will always run. And each one of these things takes its own callback. So in the case of .then, I would say something like response. And then for right now, let's just say console.log response. And then similarly for my .catch, that takes the callback, but it's what it returns me is basically an error because it only runs if there is an error. So I'll write something like that. That just prints it out in red. And then finally, it doesn't take anything, but it always runs after success or failure. And here I'll just say, I definitely ran. You honestly don't see finally that much in the wild, but it's good for cleaning things up. Like if you ever are in a situation where it's like, well, if it's successful, great. I want to do one thing. If it's unsuccessful, also, I need to handle that. But either way, I got to make sure. And that's where you put your dot finally. Cool. So let me save this. Let me see it in action. Let me run it again because that will allow me to see it in action. Great. So let me pull this up a little. Now let me just do that. Okay, so we have this here. Nothing has changed on the page itself, but this, and you'll see all this still works. But basically our useEffect, this useEffect ran exactly once because of this. And when it ran, it made a GET request. And when that GET request returned, it either printed something to the console or not. So in this case, we got our success case. And what we got back is this big object here, which tells us about the response. But what we care about is the data it holds. So maybe here I'll write response.data. And now we're just printing that. And of course, the I definitely ran is still running. Right now, I'll take out the dot finally. And I just want to show you the dot catch. So like, let's say I try to, well, first, let's say I tried to look for a Pokemon that simply wasn't in their database. Chances are, in my opinion, that's, okay, no, that will be an error. Cool. So basically, when I tried to make this GET request, it returned with a 404, not found. And what that means is that it's not going to run this dot then, it's going to run the dot catch, and that just prints the error, and the error has like a message in it. And of course, this was a real world thing. You might want to respond to that error smartly by like showing something on the page to say, you, the user, messed up. But also let's remove that right now because the dot catch is there for error handling, and we're going to assume the good case now. Okay, so what we did is that we're getting something from this API, and then when there's a response, we print that response. But that's not what I want to do. Instead, what I want to do is I want this on the page ultimately. So what I'm going to make is another use state, and I'm going to call this one Pokemon data and set Pokemon data. And it's a use state, and initially it will be null because I don't have any Pokemon data. And let's just print it out over here to say, okay, this is what the Pokemon data currently is, and we'll remove this, even though we still want to know about response.data. We will remove this just to show that initially we're just printing out null there. And then the way this works is that after the first render, we'll run this callback. We'll execute this GET request. It might take some time, but when it returns, the dot then will run. And we care about this response.data. So what we're going to do here is actually say, and this isn't necessary if it's all on one line. So I'm going to say set Pokemon data to response.data. And now what this looks like is initially it's null. Then the useEffect happens after the first render. It sends something out. And then when it comes back, calls some set data thing based on use state. And then that forces the page to re-render. So then we see this console.log. And now we have the data. So let's say we wanted to do something with the data. We would generally do something like, first we might have something here where we say like, as long as there is Pokemon data, do something. So if there's no Pokemon data, we don't want to end up in a situation where it says like, hey, that doesn't exist. What are you trying to grab stuff from null for? So if there is Pokemon data, then we render the rest of it. And what do we render? Well, we render some JSX. So let me create some JSX. And based on my Pokemon data, I see that it has like, at the very least a name, right? Species name. So I could write something like H2 Pokemon data dot species dot name. And maybe I want to show all of its abilities. So I'll make an unordered list. And then for each one of those things, so Pokemon data dot abilities. Let me look at abilities here. Okay, there's 3 of them, and each one has it gets a little annoying, but all right. So Pokemon data dot abilities dot map, and for each ability, what are we going to do? We're ultimately going to return something. And what we're going to return is, I believe, ability dot name. Okay. So we're going to have an LI for each one of these things, and that LI will show ability dot ability, to make this simpler, maybe I'll say item. So item, but this is just, how they named the data they're returning. And this should work, hopefully. Cool, yeah. So now I'm able to say, yep, Clefairy, and these are 3 of its abilities. And we can start building that out, where I can say like, well, actually, this is a little more complex. Let's say a set name here is not the name of a person, it's the name of a Pokemon. So initially it's going to be Clefairy. And then I could say something like, okay, this useEffect here, when it runs, I don't want it to just look up Clefairy, hard-coded. I actually want it to look at whatever is in name here. And then, of course, if I want it to run when the name updates, I can put it in the dependency list. This will only trigger when there's a new name. And let's just change the behavior of this input and button a little, where it'll be something like, on change, we, I'm going to just call this set input, and I'm going to remove that for now. This is called input and set input. And then separately, we'll have Poke name and set Poke name. And we're just going to recreate the pattern we saw yesterday, where this will be empty initially, and then when the input changes, I set input, that's what I called it, right, to event.target.value. And then when the button is clicked, that's when I set Poke name. When the button is clicked, I'm going to set Poke name to whatever is currently in input. And maybe at that point, I also blank out input. So set input to nothing.
You still got name in the get.
Yeah. Yeah, I know, but I'm getting a different error, which is that, yes, okay, one more of these, right. And then you are right that over here, it's looking for something called name. It doesn't know what that is because I changed it to Poke name. Let me save that. So now we have something a little better. Maybe we do want to catch that error because initially, well, actually, no, I don't want to catch the error. What I'm going to say is Poke name is initially empty. This is going to try and run, but maybe I'm going to say something, just have a very simple guard that says if Poke name. So as long as it's non-null, let's try and, or non-empty, let's try and run it. So if Poke name, do this, otherwise do nothing. And we might as well throw our .catch in there just so we can see the error, because we want to see what happens when we try and give it something that's not really a Pokemon. Cool. So I think this is now like a pretty complete example. I can put in a Pokemon name here. Oh, I have to, this also wants to be Poke name. Okay, there initially is no Poke name, and then I start typing Pikachu. Did I spell that right? Pikachu? No, Pikachu. Okay. I think that's right. So I start typing Pikachu, and if I were to look in the components thing, and I were to look at my learn useEffect component, I see that the first state, the input state, is updated to Pikachu, and that knows every time I add or remove something, but it's only when I hit click me that this button stuff runs. And so then it's going to actually set the Poke name to input. So I'm going to do that. Click me, sets the Poke name to input. That triggers this dependency list thing. The useEffect runs. It's non-empty. It tries to get it. And then what actually happened here? Well, I believe it ran successfully. And so it set Pokemon data. And now we see the Pokemon data here. And then I'm getting an error around the key thing because that's like, you know, that happens.
It didn't change the title.
That's right, because I took that logic out. I should have been more explicit about that. So that logic is no longer there. As you see, I took that useEffect out, but if that useEffect was in there, we could still do all that stuff. So if I had to use it, like useEffects are separate from each other. So I'm going to have this thing and it's going to run, let's say, every time Poke name updates, which really implies they should just be one, or they could, I mean, I guess it doesn't matter. They like basically you could even have the same dependency list for multiple useEffects if you want to split it up that way. And then this useEffect will just handle setting the title to whatever Poke name currently is. So initially it's empty, and I guess then it gives me localhost whatever. And then I'll say P Squirtle. Say Squirtle. Hello Squirtle. We see Squirtle, and you see it takes a second because it's, you know, talking to some API, and then we see Squirtle up here. So let me stop for a minute because I've gone a fair amount into this. And the purpose of this is just to demo and say, like, this is where we're heading. So it's okay to not understand this so well right now, but this is what I've just demonstrated is essentially everything to useEffect. Much like useState, it's not that complicated. The complexity is just in the details of what you're specifically trying to accomplish, but you basically have a callback function and a dependency list. Dependency list triggers the callback function to rerun. And depending on what that callback function does, you can update data, update the page. So I see a lot in the chat. Let me look at it real quickly. I don't know what I'm looking at here. But yeah, open to, let's just take some questions for a little bit. No wrong questions. I would not expect you guys to know this already. So, but
yeah, could you go over like line 11, the dependency list? What is dependency list? Poke name. What is that doing for the useEffect function?
Yeah. So that's the most complicated part of useEffect, that it has this second thing called a dependency list. There's three things that it can look like. One, it can look like nothing. If it's nothing, it runs every render. So let me reload this. You're not really seeing anything because Poke name is the same every time, and because nothing is triggered or re-render, but every time it re-renders, this will happen. So if I take it out of here, now we'll really notice this, because this means I actually wonder. So I guess it, like here, I'm going to trigger that. That should have, yeah, that would, this runs on every re-render. So when I updated Poke name, that, you know, re-rendered things. And so this ran and we got our error. It's fine in this case, but running after every re-render can be very dangerous because depending on what you're doing, you could very easily end up in an infinite loop. So what you'll see most often is this. This means I'm giving it a dependency list, but an empty dependency list. And this means it runs exactly once on the first render, nothing else can update it. So let's say I type Pokey or whatever, I just type Squirtle here. I hit click me. That Pokey name now does equal Squirtle, but notice nothing happened. And that's because on the first render, Pokey name was an empty string. After that first render, it tried running this useEffect, but Pokey name was empty, so it didn't do anything. Then I typed some stuff in, I hit click me, that updated Pokey name, and that triggered a re-render. Even though it triggered a re-render, because of this empty dependency list, it ran just that first time, never again. What you can do instead, though, is say Pokey name for either of these. And what you're saying there is if Pokey name ever updates, this useEffect is dependent on that Pokey name changing. So if it changes, rerun this effect. And that could be a list of things. So if I wanted, I could say something like, it doesn't really make sense, but I could say input here. And then every time the input changes, this also runs. So I'm going to just start typing. And that every time I type, that should have triggered. Yeah, as you see, now that it's set up, every time I type, it's triggering this useEffect again. It's doing another Axios call, and it's failing because most of what I type in here is not valid, which is why we wanted to separate, typing and keeping track of that from knowing the final thing. So I hope that answers the question. The dependency list is for triggering the useEffect.
Yeah, I think I was just confused at why you chose Pokey name. It's because Pokey name is the state that we're trying to change, like in line 6. Pokey name, we use that for use state, and then we're always constantly switching between like different types of states, I guess you could say.
Yeah, no, it's a good question why we're using Pokey name, because basically I don't want to, like, let's say I had nothing like this here. I just said, okay, when, every time this useEffect runs, including the first time it runs, just run it, and anytime input changes, run it. So I'm gonna hit save, I'm gonna reload. This is what it looks like initially, and it made one initial Axios call, technically 2 because of how React safe mode works, but it made one call because it runs after the first render, and that always happens. And now it's going to run every time input changes. So I'm going to start typing Squirtle, right? Notice for every time I did S, Q, U, R, whatever, every single time input updated. And so it triggered another call. The reason I did it the way I did it is because basically we have this input, and every time there's a change, we're going to update the internal representation of that input. It's only when we click the button that we're saying, actually, I'm in a final state, now trigger talking to a backend. So we want to make a distinction there. And so Pokey name represents someone having clicked the button and knowingly said, yes, I want you to make a backend call. And, I can make that more explicit. So now I click Squirtle and I see something, and I don't want it running every time I, say S, I can't think of any Pokemon. Charmander. So I don't want it running every time I type one of those characters, but I do want it running when I click that. So does that answer the question?
Yeah, it definitely made more sense the second time. Thank you.
You mentioned that the two useEffects could have been combined. Could you show what that looks like?
Sure. Who is talking right now? Because my Zoom doesn't always show me when someone talks.
This is Dan. Hi.
Oh, there we go. Now I see. I don't know why it delays on that. Cool. So you're asking how I could combine the use effects, you're saying?
Yeah, you just said that like those two use effects technically could have been one use effect.
Yeah.
Just like nesting the document title inside.
Yeah. So the reason I said that is because a use effect is basically defined in some sense by its dependency list, in that that callback will run when that when anything in that dependency list changes. So what I did here is fine, which is basically I have two separate use effects and both of them get triggered when pokey name changes. But because of that, I could just as well copy paste this into here and say, okay, this callback function does a couple things. Whenever pokey name changes, I will first update the title to pokey name, and then I'll execute this call to the backend and respond to it in some way. So this should work where if I start typing Squirtle here and then I hit make a backend call, immediately this will update, and then it will also send the message. So yeah, you can combine them.
Sweet things.
And
Yeah.
just for clarification, the dependency list, those variables don't have to be state variables, right? Like they could be any kind of variable.
Technically, they can be any variable, but then ask yourself the question, this dependency list is basically looking for changes. So it will only respond to when the thing changes, right? And React only knows something changes if it's use state. So if I said something like, just like const my value equals 44, I could put that in here, and if 44 ever changed, then yeah, it should trigger a re-render. But then the question is, how do I change that? Let me make it a let. Like if I wrote this, and then at some point I said, my value equals 33, that's never going to get, like, as far as it's concerned, there's just a value called my value that's 44. It's never changed. I think what is in here is either going to be a prop or use state. And if it's a prop, it's because at some level of the program you're using use state, and that is, registering the change. So the prop updates. So then the dependency list knows to re-render. So ultimately, it's going to be some form of use state that React is aware of, I believe. Yeah.
Can I hook into a database? Can useEffect hook into a database?
Kind of. I mean, useEffect can talk to a backend, and that backend can talk to a database. And
so if a value in that database changed, would useEffect trigger?
Well, not directly. What could happen is that I could say something like axios.post or something, or maybe I just say like whatever it is, I can say like axios.get this value, right? And then I could maybe I do some kind of polling thing where I set it up so that this, instead of this returning a dependency list, maybe I say like I could use set timeout or set interval to just say like, actually, this is polling. So like every, 2 minutes, try and, grab this thing from, try and do this get request. And basically if something in the backend did change, my get request would know about that. And if it was using use state, it could keep track of what it was and that it has changed, and then do something in response to that. So the backend will, or the URL based, the RESTful API will always be an in-between between a front end and a database. There's no way, for good reason, there's no way for the front end to directly know about an update in the database. And in many ways, a backend and an API is really just there so that a front end can talk to the database, but in such a way that the front end can't just say, drop all tables. Like there's this, a front end can say, I want to do this. Here's some values. As long as everything's okay, the backend can choose to update the database and then return some value to me. But the backend is there to control access to the database and respond to input. Okay, well, this was just the demo section. We're going to get to the real meat of it. Or we're going to start from the basics and build up to this now. But it's been a little less than an hour, so we're going to give you a 15-minute break now. See you guys at 10:15 CST. Okay. If we're ready to come back, let me hear you say, yeah. Now all the ladies in the house. No. Nope, I'm not a DJ. Okay, so let's go through this stuff. And while we do it, we'll probably have probably switch back and forth to this this demos and notes thing. And in demos and notes for today, I have this little thing called Async Vanilla.js, and that is where we will start. Okay, so ultimately what we're trying to learn about is how to talk to a backend in React. And we've seen this already. So just by following the patterns we've seen in the demo, you can get it done. But there's a couple of things that, like, if you really want to understand it, you got to build up step by step. And it starts with JavaScript, because JavaScript is the language and not all languages are the same. A lot of languages tend to look the same on the surface, but when you dig in, you find out details about them. One important detail of JavaScript is that it is fundamentally asynchronous, sometimes just called async. What does that mean? Okay, well, first, let's look at some synchronous code. So I see here I have this website that helps me visualize how JavaScript works. And this is that website right here. So I can put some code in here. And if I hit run, I can make it bigger so we could see the whole thing. Essentially, we can go through it step by step. It's saying, first, there's this concept called the event loop, which is basically a loop JavaScript does in order to do things. So first, it's going to evaluate the script. It sees a function. That function now exists. Then it sees something called say. Then it sees a call to that function, say my name, immediately prints A. Let me get this out of the way. And you see that added to the call stack. And then it executes, and now it's not on the call stack. And then we run the next line, this set timeout here. Notice it added it to this thing called the task queue. And then next step, we're calling say my name with C. It gets added to the call stack. It gets executed, name is C. Next, we wait until now there's nothing in the call stack. We wait, and this task is now going to get run. So after we ran everything in the script, we start running any tasks, sometimes called events. And then that now gets taken off the task queue, put on the call stack, and ran like it's normal code. And we see name is B. And most languages do not have this ability. So in Python, there's no way to say print A, then not wait 2 seconds and then print B, but rather set a timer to print B in 2 seconds, immediately move on, print C, and then eventually 2 seconds later, something will happen. So Python is sort of a normal language in that it just goes top to bottom. And if you want your program to wait for a period of time, you just have to say wait, and nothing will happen. And then it will execute the next line. But there's kind of no way to do things out of order. But in JavaScript, there's these two separate ideas. There's synchronous code and there's asynchronous code. When you hit synchronous code, it does not continue until the current statement is completely finished. So if I'm running do something here, this will run. And then after it's done, this will run. And then after it's done, there's nothing left to run, the program finishes. But there's also this idea of async. And frustratingly, there's no way to just tell just by looking at it what is synchronous, what is asynchronous. You just have to know that certain functions in JavaScript that are built in allow you to access this asynchronous functionality. So here we have function say my name. Oh yeah, let's walk through this first. So these are the steps in synchronous code. The program starts running, okay? The first thing it sees is this do something function. It's not executed. It's just evaluated to say, yes, there's now a function somewhere in memory. And then we hit this next line and we do that thing. And then when it's completely done, we read the next line, we do that thing. When it's completely done, the program terminates. And let's just copy paste this over here to our to this view. Okay, and now if I run this, I can step through it. And it's like I said, we evaluate that. It exists in memory now. And it's a little hard to see, but basically we ran, I don't know why it's like highlighting this and not highlighting the next thing, but we run the first do something, which means to add it to the call stack. And whatever that takes, we run that until it's no longer on the call stack. That code is finished running. And then we run the next thing, which adds something to the call stack. And then that finishes running and we're done. So that's how regular synchronous code works. And I'm just going to trust that you guys understand that right now, but that's the baseline where we're starting. Code runs top to bottom and a given function is not, a given line of code is not moved on from until it has finished executing. Okay, so our second example is going to be purely asynchronous. So this starts the same way that anything else does, where we're going to run through it. And first, say my name is seen, and that exists in memory now. And then the next thing we run is set timeout. Set timeout is a built-in way to access async in JavaScript. It takes two arguments. The first is a callback. The second is a timer. And the way this works is that it is not added to the call stack. It's added to this other thing that only exists in JavaScript called the task queue. It also has a timer associated with it of 2000 milliseconds or 2 seconds. So what happens, and we'll reload this so we can see it. We hit run, right? The first step is to evaluate the script. That happens pretty quickly. And then the next step is to empty out this task queue. So we're going to keep running only once this call stack is totally empty. And because we didn't add anything to it, it is totally empty. Only once the call stack is totally empty, which means all synchronous code is run, then we start looking at these things that we registered to do later. And once the timer is up, and the timer starts counting here, it doesn't start counting like when it gets like the timer starts counting here. And so as long as the synchronous code is done and 2 seconds have passed, this callback will now execute. And that's why it's passed this way as a callback, because we need to call it later. And when it's called, it will just call this function and print say name. So now it is removed from the task you put on the call stack. And now it works just like synchronous code. It's running in real time now. Okay, so before we move on, I want to see if we have any questions about set timeout, because this gets relatively confusing once you start mixing synchronous and asynchronous to understand the order in which things execute. So any questions about set timeout? Okay, so we don't have questions about it. I would love a way to find out if no questions means very confused or no, we understand. But yeah, so set timeout works in that asynchronous way. And everything we're describing so far is this thing that you can generally call the event loop in JavaScript, which basically means run all the synchronous code. And when it's done, run the async code. Yeah, I mean, if you guys are very confused, I'm reading the chat, please say something, because all I can do, if no one says anything, I don't know where to move the conversation. And if I'm already too far, we should back up. But I get that it's hard to put yourself out there and say you don't know something. So we are definitely going to work on some means of anonymous feedback. Okay, so now we're going to take the most complicated example we've seen yet, in which we combine the two. So coming here now, I'll put this in here. And can anyone walk me through what they think will happen? And I'm telling you, importantly, you don't need to know the right answer. And also, I get that it's hard to be like, to put yourself out there in class, but a good 80% of engineering is just having conversations, and revealing ignorance doesn't make you stupid. It means you're primed to learn. You want to know when you don't know something, and you want to say when you don't know something, because if you know that you don't know something, someone else might be able to give you an answer, and now you know. And that's the goal, to understand. So I would love to hear, I guess, I don't, Nick is not in here, right? I know we have some app to call on someone randomly. I just want to guess about what's going to happen when we run this code.
I guess I'll try.
Yeah, go ahead.
I think it's gonna set name to A, then it's gonna wait 2 seconds, then it's gonna set the name to B, but instantly set it back to C.
Yeah, so what you think is going to happen is that first we're going to print A, because this say my name function just is a wrapper around console.log. So first we're going to print A. Then we're going to wait 2 seconds and then print B, and then print C. Am I getting you right?
Yeah.
Yeah. Well, that's a very good, that is what is sort of natural to assume, because we generally read things top to bottom, and that's why async can be so confusing. But we will see when we run it what happens. We run it, and let's walk through it step by step. And let's read this. So it says the event loop first evaluates the script and synchronously executes the script as though it were a function body. Okay, and it runs until the call stack is empty. So we step, and we see this, but then the first thing we execute is calling say my name with A. It gets put on the call stack, which means the function gets run. We actually see name is A printed here. And now that that is done, it gets popped off the call stack. And then the next thing that happens, notably, because it's a set timeout, it's async. So it gets put on this queue, and a timer is associated with it for 2 seconds. And then it immediately moves on. It does not wait 2 seconds. It immediately moves on, because we just registered a timer to do something in 2 seconds. But the idea is that'll happen later. Right now, let's keep executing our code. It goes to the next say my name. Because that is synchronous, it immediately goes on the call stack. We print C. We keep stepping. Call stack is now empty. Once the call stack is empty, that is the trigger for JavaScript to start popping things off this task queue. So let's run our first task. We only have one. Now that, even though it's called anonymous, it's this function here, that gets added to the call stack. And now that it's as if we, just wrote it in real time. So that gets executed, and we see name is B. So it actually prints A, C, B. And this is odd behavior that's worth getting, that you have to get used to. I appreciate being able to put yourself out there and guess, because even though you guessed wrong, your guess represents a conceptual framework that is very reasonable, because that's how Python would work. That's how synchronous code works. If you want to wait 2 seconds, you wait 2 seconds and then you do the thing. There is no set a timer, do it later. I'm moving on right now. Someone else will figure out executing that thing in 2 seconds. So yeah, that is weird. But that is how synchronous and asynchronous works. And note that the idea of it is that all the synchronous stuff happens before any of the async stuff happens.
I have
a question on
Quick
that one.
question.
Oh,
Boom. Yeah. Anyone go ahead. And it's very, I'm happy to hear everyone has questions, because this is the weirdest, this is weird. And it should make you say, that's not how it works normally. So yeah, questions are appropriate.
for for like line 7 on that, does it start counting when the stack is empty, or does it start counting right away?
Great question. Starts counting right away. Importantly, though, doesn't run until all the asynchronous code has run. So, yeah,
So it doesn't matter how much time you put in. Oh,
exactly.
does.
So
okay.
I have an example about this later, but this is the example that generally throws people off and forces them to learn how async actually works. Okay, so what I'm saying now is call say my name in real time with A, then set a timeout for 0 seconds, and then call say my name. If all that mattered was the timer, we would expect ABC, right? But what actually happens? Okay, well, we run the first thing, we get an A. We run the second thing, it's added to the task queue with a timer of 0 seconds, which means it's added to the task queue, but that timer is already expired. Next step, we run the next line, say my name, we print C. Finally, nothing on the call stack. We start popping things off the task queue. This immediately goes and we print C. And the only difference between this and the last example is that in this case, the minute say my name C is done, it's going to call say my name B. Whereas in this case, if I say 2 seconds, if basically it's going to start counting here, but this is probably going to take like 10 milliseconds to run. And so even after this runs, it's going to wait, 2 more seconds, more or less, 1,980 milliseconds. And then it's going to run this. So the timer starts running immediately, but even if the timer is 0, it still doesn't run until after all the synchronous code runs.
So if you're running a bunch of code and you have the synchronous functions kind of like setting up the data, the timeouts, would you more or less use that as sort of an ordering? Like if you want quick responsing, say, okay, here's how I want it to load after everything's already rendered, set timeout for say my name B1, say my name D2 or something like that. Like, would that be an effective use, or would you still want to give it a wide berth of 2 seconds, even if things will load very quickly?
Yeah, so first I'll say that when we're using set timeout is sort of this like the most primitive async thing we have in JavaScript, but practically speaking, you won't often use it. But it highlights the point of async and why async is central to JavaScript, because imagine you're using a website, right? And let's say JavaScript was totally synchronous. You're using a website and you want this website to be responsive. So every time you click on something, you expect it to happen right away, right? And let's say you click on a button and that button requires that it speaks to a server. And then that request has to wait to get a response. Because it's synchronous, it has to wait to get a response, and then it does something. If JavaScript was purely synchronous, if you clicked a button that talked to the backend, until it responded, it couldn't do anything. And so any button you clicked, anything you did on the page would not respond because it's busy waiting. And so that's why async is central to JavaScript, because they knew in the very beginning of the web that you would want to maintain interactivity while you might be waiting for something. And because basically because of how the internet is, even when it looks relatively fast like this, they were assuming dial-up modems. So they were assuming like you might have to wait, 3-4 minutes to get that response. You don't want the page to just freeze for 3 or 4 minutes. Yeah, so that's if I answer the question, that's why async exists. But practically speaking, once you're using React, you won't be using set timeout. Rather, calling an API is your version of set timeout. You're basically saying, the way you can mock an API is just saying, set timeout and then do the thing after 3 seconds, because that's just mimicking the fact that talking to something far away takes time. Cool. So we're gonna
And
keep.
one more question on this. Sorry.
No, by all means.
So is there ever a situation where there's like still a bunch of stuff on the call stack, and then if we go back to that example you had earlier, so the say my name with the letter B, if that's still in the queue and all of a sudden the time elapses and then now it's time to execute it, is there ever like a precedence of who gets executed first, what's left in the call stack, or who's in the task queue, like who has precedence?
Yeah, well, the call stack always gets precedence. The call stack always gets precedence, but that doesn't mean that in terms of determining order of execution, for synchronous code, it's easy. It's just the order in which you wrote it. So this runs, and then this runs. And really, this runs, then this runs, but it just sets something up, and then this runs, but it just sets something up, and then this runs. Let's actually run this. And we'll see that we're going to step through it. First, we add, the A, then we set up D, but in 2 seconds. Then we set up B, but in 0 seconds. Then we immediately do C, you see C. Then we start popping things off of this queue. And which one do we think is the first to go? The one that was added first, or the one whose timer expired first?
Added first?
I mean, it really could be either. So let's see. I believe it's printing. Okay. So it added something the call stack. No, it's B. So it's the one that expired first that gets called first, and then the one that expired second. And so this is why async is confusing, that it's pretty easy to understand by reading top to bottom what order things executed synchronously, whereas for async, it can definitely get more confusing because right now I'm setting timers, but let's say I made 2 API calls, right? Just because I sent one out first doesn't mean that's the first one to come back. Could be the one I sent after came back faster, because who knows why? Maybe the first one required, a long operation at that end. Maybe the server is much further away. And so a lot of problems in web development boil down to like the fact that when you talk to an API, you don't know when it responds, and you can't guarantee, or without being careful about it, you can't guarantee an order in which things happen. So yeah, that is the answer. That for right now, it's based on the timer, which basically is the equivalent of when it comes back. That determines the order of execution. And this actually leads us into our future topic, which is promises, because you can already see, and we'll dig in a little deeper, like just having this callback system, whether it's after a certain amount of time or whether it's in response to something like a API response coming back, it's not a very powerful way to control like order of operations. And promises are essentially this solution. It's just, a JavaScript object, but it's a solution that allows you to have more fine-grained control of the order in which async stuff happens. And we're going to see that in a minute. So any more questions while we're here? So this is the example we just saw where it actually goes A, C, or A, D, C, B. And this is all explained in a little more detail. And importantly, this is JavaScript is async, but it's single threaded, which means you might think that you could say, like essentially if you have if your computer has like a CPU with multiple processors, what that means is that technically you could say, okay, the main thread is going to be, doing something. And then I can tell the, a side thread, oh, start doing something else, call an API, do something else. But JavaScript is not designed assuming you have a multi-core CPU. It assumes there's only one thing happening at a time. It just has, because of the event loop, it has support for this idea that some things happen immediately, some things happen later. And as explained here, the main reason why async is front and center in JavaScript is because we want to make sure the user can continue to scroll through the page and that the page is responsive to the user's commands and events, even if, you're waiting on some call to return. Okay, so the
Is that the ultimate reason why when you're buying something it says only click on the button once?
I mean, yeah, it's part of the reason. The reason why they're saying that is because if they designed it poorly, if you click on it once and then click on it again, that's going to send 2 requests. And basically they should, I really think it's the web developer's responsibility to make sure you don't click on it twice, so they can force that to happen, like they can disable the button. But yeah, generally, if you clicked it twice, for each time you clicked it, you're sending a different request, and maybe one completes before the other, maybe one completes and then the other doesn't know that the other completed, so like you end up purchasing the item twice. So the problem with async is that you can run into these things that we call race conditions, which basically means that unless you're being careful, you can run your program once and, something happens in order where, let's say you call API A and that comes back first, and then you call API B and that comes back second. And the next time you run it, just because the world is a little different, B comes back first and A comes back second. And if your program doesn't work, or if your program works in one situation and not the other, then it's not so well designed. And it's essentially it's just another kind of bug that, part of the reason Python is purely synchronous is that it doesn't really need this feature of like, we need things to stay responsive, because that's not really what people use Python for. And so Python as a language choice eliminated an entire class of bugs by not including this feature. And in JavaScript, by including this feature, they open the door for weird bugs in the form of a race condition. Okay, so just going back to see an example, just going back to Node right now. If we were in Node and we tried to use the file system library FS, by default, Node works like this, where this read file function is async, which means the first thing we're going to do is execute this, but because it's async, it actually doesn't happen right away, and that's why we provided a callback function. And then before any of this callback function code is run, we'll print hello world, because that's synchronous. And then once that is done, the program says, okay, now I can do this because there's nothing else pressing to do. All the synchronous code is done. So it tries to read this file and then run this callback function after it reads the file. And if it wasn't able to, error has a value. If it was able to, data has a value. And then this is how it handles errors. You just get it passed as an input, and then you could do something about that. And that is fine. Callbacks work for doing async, just like we saw with set timeout, but they end up scaling poorly. A lot of bad design in programming is just because when it scales up, it doesn't work so well. And so what does it look like if you had a really complicated task with FS that you were trying to do synchronously? Okay, so this is what it looks like. We're going to say read from this directory. If there's an error, print something and throw the error. Otherwise, you have a list of files, go through each file. And for each file, we're going to want to read that file. And once again, if it fails, we're going to get an error and print it and throw it. Otherwise, we're going to have, we're going to create this new file path, and we're going to create some new content based on the old content, and we'll write the new file to that folder. And assuming it doesn't fail, we're good. So this is kind of hard to read, right? And there's two things to notice. One, we have to indent a fair amount. There's a lot of if else going on. And if you have to do a lot of things in which you do something async, and then in response to that, you do something async, and in response to that, you do something async, you end up in this thing called callback hell. And callback hell basically means it is hard to track what is running when. And also you get this pattern where it's sort of like your code keeps going in and in and in. And there's like a funny picture online, which is basically Ryu from Street Fighter doing a Hadoku, and he's pushing all the code to the right, because over time it will just get further and further to the right. And anytime you have too much nesting, it doesn't feel right. It's harder to read. And then the other thing to notice is error handling. I'm having to handle the error at every single stage uniquely. And it's hard to know what happens. Like, let's say the first two things work, but the third thing is an error. Like, you could just see this, even this small program is going to be a nightmare to debug. Okay, so we see these problems, right? If I'm chaining a callback in response to another callback, requires another level of nesting. 2, error handling is awkward. 3, it is hard to follow what happens when. Execution order. Okay. So everyone saw this, and after a while, someone came up with a good solution called promises. And to show you how promises work, the first one we're going to do is define a promise. So let's see if I have a nice little example of this. Yeah, I do. This is a little complex, so let's start just over here. So I'm showing you how to define a promise. Often you do not do this yourself. Often you simply, like, if you call axios.get, that returns a promise. They handled creating the promise. You don't handle creating the promise, but it's worth seeing how a promise is defined in order to understand how it works. So a promise is an object like any other. So you call new and then promise, and then it takes exactly one argument, which is this whole thing here, which is a callback function. And that callback function takes 2 values, one called resolve and one called reject. And I know this is getting complicated, but each one of those values is a callback function. And the idea is that in this case, I'm just using set timeout to say wait 2 seconds. But after 2 seconds, I'm going to execute this code. And basically, if this math.random is less than 0.5, I call resolve with an object that looks like this. And if it's greater than 0.5, I'll call reject. And these are the 2 paths in which a promise can take. A promise is either rejected or resolved. And depending on which one, we either execute, as you see down here, what we saw before. If it's resolved, that means success, we execute the dot then. If it's rejected, we execute the dot catch. Either way, once either is run, we execute the dot finally. And I see this picture is not showing up here, and I want it to. So why is this picture not showing up? Page resources, promises, .webp, it should be in there, but it isn't apparently. And that is, okay, we can just quickly see a picture of it. If I just Google promises.js, the picture I want to show you is some version of this, which is not so complex, but it tells you what a promise is. This is actually horrible. This is incorrect, so don't look at that. It's this. Basically, a JavaScript promise starts in a default state called pending. and then it is either fulfilled or rejected. Once fulfilled or rejected, that is its final state. Just to see this running, I'm going to create a new file here. I'll call it, I'll just call it 3 basic promises. Okay, and I'll get rid of all this. And just because we want to see this working, let's create such a promise. And the idea of this promise is that after 2 seconds, it's going to change. It's going to either resolve or reject. So what I want to do is say console.log my promise. Okay. And let's see what that looks like when I run it. Am I not on the right folder? No, I am. Async vanilla.js. Node 3. Okay. So that's all I wanted you to see. The promise was pending initially. So when we initially run it, like a promise is just an object, and this callback does not get run immediately. So we create the promise and it has this callback. And well, actually, I guess this callback does run immediately, but what is inside of it takes 2 seconds to run. And then we immediately move on to the next line in which we print, okay, the promise is currently in the pending state in which it starts. And then we're getting this unhandled promise rejection, and it says it doesn't, it errored out, but it doesn't have a dot catch. And it's complaining because I didn't respond to an error case in this promise, and I guess we hit the reject case. So I'm printing it out initially, but then I could also say my promise, and I say dot then. And what we're doing here, we're saying basically when, if and when resolved is called, this is the function I want you to call. So whatever was in here gets passed in as the input, which I'm going to call data. And then within here, I can say, and some people like to do it like this. So I'm going to say dot then, and what happens in the case of the dot then, I say console.log resolved. And then I'm actually going to print the promise itself so we could see what state it is in. And then I can actually say, and this is what I received in the form of data dot. We see message as success, but data dot data, I guess. I believe I'm just going to type data, and that's going to be everything that it returned. And then similarly, I can write dot catch, and dot catch is going to take this object I call error, but it's whatever is passed into reject. And then I'll print this and say rejected. And then I just want to print that whole error object, so I will. And then just to show it off, we can have a dot finally. And we just say console.log either way. Okay, now let's run this again. It's pending. And then it resolved. This is what it resolved to, or this is what the promise looks like once resolved. And this is the message we got. And then this runs either way. And now I'm going to run it again. And because of the randomness, we get an error this time. It rejected. So this is the essential API of a promise. You generally don't write this part yourself, but basically it's something that might take a while. And each one of these dot thens, they modify the promise so that when resolve or reject is executed, it does something, but it doesn't do something in real time. So it immediately moves on. Like this dot then just registers, yes, this is what I will do when that happens, but nothing happens right away. And here is where we say, like, I happen before any promise resolution. So we run that, we see the promise because that's perfectly async. We see I happen before any promise resolution. We see then it is rejected. So this runs, and then this runs after that because something happens. So either way. So yeah, this is the essence of a promise, and let's dig in here with questions. Let's have a look at the chat for a second. If it does make sense, I'm happy, but something I always want to impart on bootcamp students is it's easy to feel overwhelmed by this stuff, but it's worth remembering that like web development got by for a solid 20 years before someone came up with this really good abstraction called the promise. And now we're teaching it to you like, oh, callbacks, promises. But for a lot of people who lived through it, it wasn't you learn about callbacks and 5 minutes later you learn about promises. It's you learn about callbacks, you use them for a decade, and you notice all the problems with them. And then when promises are introduced, you say, oh, yes, that addresses the problem. So sometimes it's hard to even see the why of some of these more like advanced tools. But I'm sure you can appreciate that this looks simple in a way that, where was it? It looks simple in a way that this absolutely doesn't. And for instance, FS has, promises now. So I think, do I do that ever where yeah, so this is my example here. If I were to use FS's promise library, it just looks so much simpler where instead of, saying, in our first case, we had something like, even though it's not that much more complicated, in our first case, we have this callback function and it has to determine if something's an error or data. And it just looks a lot neater here where I say, if I'm using the promises version of the library, I read the file, and then if success, I follow one branch. If error, I follow the other branch. Yeah, so how are we feeling right now before we move on to Axios and promises? I'm gonna check the chat again. Yeah, async is a kind of rough topic, but by the time we build up, hopefully you will feel good about it. We'll take a break in another pretty soon. I'm aware. I guess we started again at like, we've only been going for like 45 minutes. But yeah, so Axios, is a library for making API calls, and you can use it in Node just as well as you can use it on the front end. And over here, I just made this up, but let's say I'm trying to talk to this route. This returns a promise. Axios always returns a promise. And then I can do something in response to a success state, which is going to be anything with a code of 200. And anything else is going to be some kind of error state. And then I handle that. And that error state will actually have useful info. So I'm actually going to go here for a second, and I have this Axios promises thing, and it's a little complex in that I'm also using readline here just to get some input. But basically, and I say I haven't even introduced some of this yet. So let's stick here for now. This is a basic Axios.get example. I'm trying to get this trying to talk to this URL. And if it works, I can peel off some of the data that comes back and print something. And if it doesn't work, I print the error. And okay, here. So here is my example of talking to the Pokey API. I'm just going to copy paste this. So coming here, see it says copy. So coming here, this is what I wanted to show you. And this is, we're going to ask the question, name a Pokemon, and we'll get some something back. And whatever Pokemon name we give it, we call the API, and then it will get a response. And then we're just going to pull some information off of it, which, might look a little strange, but this is just, whatever object is returned, you got to work with. So this is how they define things. So I'm going to get a name and a primary type. And then the way I'm doing it right now, I'm saying after that, in response, I want Axios to get a different URL, which comes from this type right here. And that'll return me other Pokemon of the same type. And I just want to get the first 10. And then I want to get them by name. And then I want to list them out. And you'll notice I have this catching the error here because this is a separate thing, and then catching an error here. And then finally, and that's what finally is good for, I'm going to close this read line thing because it's sort of like a cleanup thing. So let's try running that now. Name of Pokemon, Squirtle. Takes a second. And first it returned us Squirtle's information. So I'm able to print the Pokemon Squirtle has a primary type of water. And then I say other water type Pokemon include, and this is the result of my second backend call. So how do we feel about this so far? Any thoughts about like, this is good, or this isn't actually seemingly better than the callback approach? Okay, we feel good about it. So importantly, the reason I showed you it this way was to show you what you probably will think about doing, which is very often in response to one backend response, you want to make a new call, right? So I called this original Poke API thing with a search term of Squirtle, and that response gave me some information, including some information about a different API I wanted to call, or a different URL I wanted to call, to get, related types. So you see how like first I needed to know Squirtle's type, and only then could I look for other Pokemon with the same type. So this is two separate API calls, and they're nested right now. So this does work, but notice we have a lot of the same problems we had with the callback approach, as in when we have, when we have a promise that that in response to the promise triggers a new promise, we're nesting, we're going a level in. And then also we're having to catch the error uniquely at each stage. So the catch here is unrelated to the catch here. Okay, so we still have most of the issues of callbacks. What are we doing? Well, there's a little more to the promises API. So now I'm going to show you the right way to do it compared to that way. And this is what it looks like. So pretty similar, but what we're doing first is we're saying Axios.get. We're trying to get that, Squirtle, and we get a response. But here's where it's different. Instead of within the body of that dot then executing a new promise, right? Instead, I execute that, or I do that new GET request, but I return it. What does that mean? Well, by returning it, I'm able to do this thing where now there's going to be another dot then. Whatever was returned from the first dot then is now, when it's resolved, the input to the next dot then. And then finally, if either this or this fails, they both result in the same dot catch. And then of course the dot finally still works. So it might not seem that different than before. Let's see if we can just go back and forth. Yeah. So it might not seem that different, but we fixed the nesting issue, and we don't have two dot catches, we have one. And so this is the an essential point that most people miss for a while about promises, that if you want to chain promises, you don't run a promise within a promise like so. Instead, you return a promise within the dot then of another promise, and then it will simply be the input to the next dot then. So questions about this, because this is weird, like we're getting into pretty complex stuff at this point. So you should have questions about this.
Hey, Ben, I actually have a question. So you said that it solves the nesting issue, but it seems like it's still dependent upon the response from the first request. So is it more syntactical solving the nesting issue, because the functionality is still nested within one another, correct?
Yes, no, you're absolutely right. The only thing we've solved is how we write it and how nested it is visually. In terms of how it's designed, based on what I'm trying to do, there's no other way. As in, I can't find out the related types to Squirtle until I find out Squirtle's type. And this will often be the case when talking to an API, where first you say like, hey, API, can you get me all the information about the user with ID 44? You get it back, you start looking into it, and you say, okay, well, thank you for the user with this ID, but I actually want those that the user's posts. And so like some data that or maybe I want like, only conversations between this user and a specific friend of theirs. So first I have to look through their friend list or something like that. Like usually it's a multi-step process and you can't get around that. The fact that sometimes you need some data before you can even make a meaningful request for a different kind of data. All we're solving is the problem of nesting it visually. And that might not seem like a big deal when there's only two things, but if you nest something 10 times, suddenly you're like all the way to the right of the screen. And that will not happen even with 1,000 things chained together with promises.
Okay, that really helps me visualize this a lot better. And then, oh, this might be a dumb question, but just to clarify, the type of responses don't have to coordinate with requests don't have to coordinate with each other, right? The original GET request could then return a post or a put request or even a delete request afterwards?
Sure, yeah. So what we're doing here is just saying return this promise. As long as it's a promise, it'll trigger the next dot then. And what ends up in the response is whatever that backend call returns. Could be nothing, could be JSON, could be HTML. You don't know what that, like whatever that API says it returns. That's what ends up here. The only requirement is that this is a promise. And actually that is not even a requirement, because if I just wrote like 44, something that isn't a promise, then it will just immediately execute this next dot then, and response will equal 44.
Awesome. Thank you. I really appreciate it.
No problem. Yeah. Cool. So we're definitely building up, and that's good. I'm going to let you guys break in a minute. I'm realizing there's a fair amount in this lecture. The last thing I want to show you before we break is this idea of promise.all and promise.all settled. So we'll just look at the example here. But essentially, sometimes you want to, make multiple requests at the same time. So let's say I had the situation where I say, okay, I want to get Pikachu and Squirrel's information. They're not directly related to each other. I don't need Pikachu's information before I get Squirrel's. They're just two separate requests I want to make. And so the way we would do that is with a promise.all, and a promise.all takes a list of promises. That's why I wrote it the way I did. And then in response, you'll be able to pull off, each one, like you'll get a list of responses. And you'll be able to pull off each one and, show the data. So I can just copy paste this to show it working. And when I run this, I'm getting both Pikachu's and Squirrel's moves. And I have no idea which one of these requests completed first, but it doesn't matter because I'm only running this dot then once I got all that data back. And that's the reason to use promise.all instead of just saying, Pikachu.get and Squirrel.get, because if I do it that way, I can't actually control which one comes back first. Whereas this way, I don't care which one came back first. I only know when they both came back. And then I can choose to do something with what came back in whatever order I want. Okay, and promise.all is great, but it actually has a big problem with it, which is that if anything within the promise.all rejects, it doesn't work. So we're going to show that by adding this broken link here. So I'm adding broken here. That's just not a real link to anything. It's not going to work. It's always going to fail. And I go like this. And what happens here? Let me run it. We got an error. Why did we get an error? And notice we don't see anything about Squirtle or Pikachu. We just have an error. Why do we have an error? It's because if any one of these fails, the whole thing fails. And that's kind of rough behavior because I don't know. That's not the default behavior I want. So what is the solution? Well, this tells you a lot about web development, that the solution took a long time to come, but it's called promise.all settled. it's basically what you wanted .all to be, but .all was not initially. So how does promise.all settled work? Let's see that. So with promise.all settled, we still take a list of promises, but importantly, we don't have a dot catch here because this can't fail. Instead, we do the .then, it returns us all the responses. I'm going to walk through each response. Each response has a status on it that is either fulfilled or rejected. And then I can choose to do one or the other based on whether it's, fulfilled or rejected. But now when I run this one, we got the Pikachu, we got the Squirtle, and then this one failed. So we write it failed. But promise.all settle is very useful if you just want to set off like 10 promises. You don't care about the order in which they happen. You just want to get them all back and find out which ones were successful, which ones were failures. And like, for example, like I remember one time at a job using the front end, we were like incrementally patching a database by just saying like, just go through this list of things and, update every entry with the data. And if you try and use promise.all for that, if a single one of those requests fails, nothing happens, and that's terrible. So all settled is way more useful. And I'm going to give you guys a break now. Let's come back at, I suppose, let's come back 10:25 or 11:25 CST. All right, see you guys in a bit. Okay, we're back. I see we have a little more than a half an hour left, which is not that much. It's ended up being a pretty big lecture, but I still think it's worth going through it in the order we are. Because as you see, we're just trying to fill in all the details of like everything async, because we never really did that. So something we haven't talked about yet is this thing called async await, which is a pretty new feature to JavaScript, and it is a form of syntax sugar to make promises a little easier to digest. Students in the past love async await, but I think it's very important that you get comfortable with promises first, simply because async await is just promises, but like a little more obfuscated so that it looks nice. But this is async await, and let me just copy paste this and put it back in that file. And we're doing exactly what we were doing before with this file. Which is getting a Pokemon and then getting other Pokemon with the same type. And how do we do that? Well, instead of using what looks like promises, what we do is, here we're getting that search term. And first, this is only necessary if you care about errors, but we have a try catch block because this might fail. And what is this? Well, this is a function, but this function has this keyword in front of it called async. And if you have the keyword async, you're allowed to use the word await inside of that function. That's why it's called async await. So because this is an async function, I can start using await. And what I can do is say, okay, response equals await axios.get. So how does this work? Well, because this is really just promises under the hood, what happens is, it's like axios.get is called, and even the program doesn't stop, but it waits here. It doesn't keep executing the rest, because this is ultimately a promise, and it's as if all of this is within the .then. And if there's an error, instead of there being a .catch, it just throws the error, which can get caught over here. So it's as if we wait for that to happen, and then we do some stuff, and then maybe we do a different request and we wait for that, and then we do other stuff in response. So a lot of people like this. It's ultimately just the promises with .then and .catch, but it's in a way that now it reads like synchronous code. You could just read it top to bottom. You don't have to say like return the next promise. Like, it reads very naturally. So I imagine a lot of you are going to like to use this. My only warning is that if you're having trouble getting something with async await to work, try and write it with dot thens and dot catches first. And then once you have that worked out, then you'll probably know how to make your async await thing work. And then also certain things are just not natural with async await. So like if you're trying to do promises.all or all settled, that kind of works best as a traditional promise. I don't know, actually. I mean, worth experimenting with. Some people, like, it's just a style thing. Some people love async await. I'm still pretty loyal to dot then dot catch, but it could just be because that's all I had for a long time, and that's what I first learned. All right, before we move on, any questions about async await? I could also run this code to see it work. Yeah, it still works. Any questions about async await? Okay, well, if I keep reading here, finally, we get to async and React. So that's what we're doing all this for, just to show you how to use useEffect. I guess now let me show you this real world example. So if I go back to my projects here, I'm going to have a project here called useEffect example. So let me go in there. And I should be able to run npm run dev. And it works. And here it is. And this is just some of the stuff I was doing before. So let me go in there and say, actually don't want this learn useEffect thing anymore. And I want to uncomment this out so I can show you guys this great website I made. And this is using that Poke API. And I just have a list of Pokemon and some images of them. And so first I'm showing you how, first you can combine, like, you still have all the features of React. And so like, instead of making, all these different components or having one component, which has like 4 use effects, it's kind of nice to make something like this where I say, okay, there's this thing called a Poke Viewer. It ultimately represents the name of a Pokemon and a bunch of images of it. And it takes a single input, which is the name of the Pokemon I want. And then the rest of the logic is handled in Poke Viewer itself. So I look in there, and how does it work? Okay, so first I have this useState set to an empty list, which is supposed to hold the Poke Images URL. Oops, I don't know what that is. And what I like to do is I'm just going to skip this useEffect for now and look here, because the heart of your component is always going to be the return JSX. So I look here and I say, okay, I show a name. And then if I have, this list of image URLs and it's greater than length 0, then I'm going to show something. And what do I show? I show, and you see if I didn't have it, I just show loading. But if I do have it, I map each one of those URLs to an image. Simple enough. And then how do I get these images? Well, I have a useEffect here. I say axios.get that thing. And then when it comes back, I dig into it. And I have to do this just because some of the things within this response.data.sprites are strings, and are strings that represent an image URL, and I want those, but I wanted to leave out, like, there was somewhere it was just a nested object, and that was a little too much to figure out. So basically I just take the top level URLs. And yeah, this works and it's not too complicated. So this is a real world example. And how about, does anyone want to walk through with me how I might convert this to like async await or something? Or do you guys just want to see that maybe? And I'm reading the chat right now. I hear you 100%. I wish we introduced everything about async way earlier, because up until this point, we kind of teach JavaScript in this way that avoids like the essential weirdness of JavaScript, and it's there. And some weirdness of JavaScript, like the this keyword, you can just get it. You can just like avoid the this keyword forever at this point. but some things you can't get around. And async is like built in there. So yeah, I very much hope at least next time to teach JavaScript, just teach more essential JavaScript up front. Okay, so let's say I want to change this to async await. How might I do this? Well, first, I think I want an async function. And based on what some people are saying, it may or may not work. So this function right here, I want it to be an async function because that lets me get await. I'm just going to save this and see if I get an error. Yeah, this is a known thing that says warning, useEffect must not return anything. What are you talking about? Oh, okay. It doesn't like it because part of being an async function means it's returning a promise, and it doesn't like that. And so it wants me to do it like this. So it's actually telling you this is a pretty good error. It's saying the way to do it is instead within here, call a function, and you can write the function directly in here if you want, which is going to be something like const call pokey API equals a function, but importantly, it is going to be an async function. And then in there, I can do something, and we're going to modify this. But for now, I just put that in here. And then, of course, I call it by saying call pokey API. Save. Is it happy now? It seems like it doesn't. It's a little happier. So because I'm in async, I can do await. So instead of doing it this way, I'm going to forget about the dot then for a second, and I'm going to say const response equals await that. And then right below it, I could just say, okay, the rest of this code doesn't happen until I have a response. So this just, yeah. And obviously this looks a lot nicer. The more I see async await, the better I like it. But we'll reload and it still works exactly like it should work. So that's an example of async await.
And where would you catch the error?
Where would I catch the error? Oh, right, yeah. So yeah, let's say there was an error. Like for instance, I'm just gonna let's try that. Yeah, like I wonder, do I get an error if I give it a Pokemon it doesn't even know about? Like you guys all know the rejected Pokemon, Jose Delgado. It was a rejected Pokemon. They felt it wasn't Pokemon enough, sort of looked too much like the trainers. And I didn't even spell it right. Okay. But either way, it's not a real Pokemon, so it's not going to be in that database. And let's see what happens when we run this. Okay, we get this, and then we get loading. And then we're getting these errors uncaught in promise, blah, blah, blah. So we still get an error, but yeah, we want to handle that error maybe so that the user doesn't see it. And how might we do that? Well, if it was a regular promise, we would just say .catch, but because we're doing it the async await way, we would do something like this, where we have this async function, and then we say, okay, try to call that async function. If anything goes wrong, catch it. And when you catch something, you can actually capture what you catch, so you can talk about it. And in this case, we'll just say console.error, which is, I think, exactly what the browser is doing by default. Let's see, let me reload it. This is still saying loading. We're still getting this 404 error. So yeah, I'm doing a try, and then let me see, uncaught in promise. Maybe I don't want to do it like that. If I did this, just now I see I'm still getting the error here. So I actually wonder, I mean, that's a really good question because I'm not necessarily getting it right now. So maybe I want to do something like go back here. Could be the issue is that this is the thing that could fail. So what I actually want to do is something like, I wonder. Something like I would say try. And then what am I trying to do? I'm trying to do all this. And if the error happens there, then I might try and catch it like this. And then in response to catching it, let me just say console.log error. And let me see if that gets rid of the real errors. And it does. So this is just coming from the browser. It's saying, hey, that failed. And then this is us printing the error ourselves to say, hey, we caught this error. We're telling the console about it, but we don't care. Whereas the default behavior is something like this, where it's going to print an error to the console, and that looks worse. But yeah, this is how you would do it. You'd have a try catch block within your async await logic. Cool, feeling pretty good. All right. Well, keep the questions coming. I'm just going to look at the material we have to see what's next. Okay, I see. We have a little time, so I do want to do the video store part 3 stuff. But something I just wanted to mention is this. So if we look at this link here, suppose I can look at it here. If we look at this link about the useEffect cleanup function, you will see, according to the React site, that sometimes in useEffect, you actually do return something. Why? This is called a cleanup function. So if whatever you did in useEffect involves like creating something that needs to eventually be destroyed, you give it this return statement. And what that means is that it's going to run this thing. And then we've mentioned how React has this concept of a life cycle, right? So there's like before it's rendered, and then it renders, and then there's after it renders, and after it renders, we run the useEffect. Well, this thing you return here, this runs when the component is unmounted. So initially, when a component is added to a page, it's mounted. And for as long as it's mounted, you can render, re-render, etc. But it's possible to remove a component entirely from the page because of a re-render. So let's say at a higher up level, you had some kind of condition that said, like, if we're loading, show the loading component. And if we actually have the data, then don't show the loading component, show the real component. And so when we say don't show the loading component anymore, that is when it unmounts, and then this callback would be run. I can tell you that in like the 5-6 years I've been doing React, I've never had a reason to include one of these, which is why I didn't emphasize it. But it does matter in certain situations where without it, you can create some kind of memory leak or some kind of situation in which you open something, like basically you opened a file, but you never closed it. You didn't clean up what you started, what you took out of the toy chest or whatever. So there's a lot of examples here. And as you can see, like if you go through the site, there's almost like none of these hooks are trivial. There's always little things to mention, and it's very thorough. So, you might not encounter some of these problems for a long time, but eventually you will. But this is just a great resource to know about. Okay, so closing this, the final thing to do in the next 15 minutes is I want to add useEffect stuff to the video store, right? Cool. So in order to do that, let me go back to day 2, week 8, day 2, and I'll go to video store part 2. And let's just do this because we have to. And then we'll install it. And let me actually open this up in its own page. Where is it? There it is. Okay. So this is the video store. And if I look in package.json, I have some stuff, but before I even start this, I know I'm going to want Axios. So let me npm install Axios. I didn't do -- save. My bad. I think I can just get around that by running it one more time. And then it will. So you saw when I didn't do it, right? But now I have it in the dependency tree. Cool. And now I'm going to say npm run dev. And let's see what it looks like right now. This is my current page. Real good. It does stuff. Okay. So if we look at the notes for today, we mention, where do we mention it? I think we mentioned it all the way at the top, for better or worse. Yeah, we mentioned this, that we have some features for the video store, and basically we want to use this open source API called OMDB, which is some kind of IMDb database that is publicly accessible. And you might need to get your own API key, but here's one that we have. Some APIs, like the Poke API, they're totally free as far as I know. They don't care how many times you call it. They're expecting you to play nice, and it doesn't really matter. Some things have this idea of an API key, which means like this identifies you uniquely as a user. And if you start abusing your privileges, let's say you're just making a call to their backend, like, 1,000 times a second, they're going to ban you and say that person cannot, that email / API key, however we identify this person, we're cutting them off for a while. So OMDB makes you sign up for your own API key, but that's it. It's not a very complex system. And if I call this is an example of calling the API, and it takes some query parameters. And the second one is the API key, but the first one represents the ID of a movie on IMDb. So let me click this, and you'll see here some JSON worth knowing about. There's a a Chrome extension I love called JSON Viewer. Without it, this looks really hard to read, and with it, it's really easy to read the JSON. So worth looking into that one. But this is the JSON that returned when I called that. So basically, it's just an API to get information about movies. Lots of information here to want. And so how might I integrate this? So let me go into source here. We still have main, we still have app. The main thing is that right now we're relying on this local data, and we don't really want to do that. If I look inside of this data, I see that some of the stuff I'm going to be able to get from that API, some of this stuff I won't, because like copies available is something unique to our situation. Right now, we're not going to worry about that. I think by day 5, that's when we introduce like actually serving up the React app from your own backend and talking to your own API. And that's when you would have this data in a database, and that's where you'd be pulling it from. But for right now, we're just concerned with talking to an API. And so we're just going to try and create as much functionality as we can that is not using inventory.json anymore, but is using ID, title, image URL, and all that stuff is within this return thing. We get a lot of good stuff there. So the first thing I'm going to do, I guess I can just delete this whole folder if I really want to. And when I go here, I can say we don't have that anymore. And now what do we have? Well, I'm going to say, how about my inventory is initially empty, and the whole project's going to break because it's not set up to respond to whatever this new API situation is. But okay, so we have an inventory, and let's just say I want to use useEffect, right? So useEffect, and first let's just see it working. I mean, I think I'm gonna just, there's a lot here. The first thing I'm going to do is probably get rid of this just so that it runs, and I'm just going to print out, well, I guess I don't have to print out anything. I just want to see this run. So if I come back here and I look here, okay, at least it's running, and let's get our console open. Okay, and I'm just going to use that to see if useEffect is working. I'll look at the chat real quick. Nothing. Okay, so we have useEffect here. Let's use it. Without worrying about all this other stuff yet, I'm going to put it over here, and I'm going to say useEffect. Here's my callback. And when do I want this to run? I want it to run exactly once, because it's just going to run the first time and get this information. And what information do I actually want? Well, I want some IMDb. What are some? I just want to get like 4 movies. I do have this somewhere, but we can just go to the OMDB API. And okay, so we have this one, which is Guardians of the, or we have this one, which is Guardians of the Galaxy. And I'm assuming it's actually going to be like, if I just say, you know, a different one, what happens? Oh, it doesn't like that. Okay, how did I do that? Like if I say 0 here, will that get me something? Yeah, okay. So I'm just gonna, yeah, but it doesn't, a lot of the info is not there. I guess I'm just gonna quickly look up what I did for the solution. So if I open this, I'm just gonna say CD Tango demos and notes, week 8, day 3, video store part 3, source data. And I just want to see what's in there so that I can grab these IDs. Yes, so these are the correct IDs. So let me just put them here quickly. So basically, we're going to try and use an API to get all 4 of these movies. Which ones did I get? Did I get 5224, 85? Yeah, I missed 776. Cool. So I'm going to want to, these are all strings. And for, yeah. I thought I heard someone talk. Yeah, so basically this is the list of movies I want to get. And we're just hard coding this now just so we can see stuff. But let's just say we had this data, and basically this data doesn't need to be a use state because it's never going to change. It doesn't need to even be inside of the component. I could just say this is const film IDs. Okay. And then what do we do? Well, the use effect, because this empty dependency list is going to run exactly once. And when it runs, I'm going to say something like, okay, so I want to say, oh, I want Axios here too. So let me import Axios. Great. So I'm going to say Axios dot get, you know, for each one of these, I'm gonna go to my API, which looks like this. Let me just copy that. Okay, so we're gonna have something like this. And the API key will stay the same, but we're gonna put this I in there. And that I is gonna be the film ID. I'm gonna call film ID for now because I see that I want some kind of like for each, and it kind of makes sense to do like promise.all settled or something. I guess it doesn't really matter. I'm just going to do you can just do it like this, where you say, well, I can say something like film IDs dot for each, which is going to, you know, run some callback function for each one of those things. And what will I say? Well, might as well make this an async await thing. So I'll say like, I guess something like update inventory. And what is update inventory? That's a function we're going to create right now. Okay, so I'm saying something like film IDs dot for each. So each time this is called, it gets a film ID, and inside of there, I'm going to say, I can include a try catch, but right now I'll just say Axios dot get that film with that film ID, and I'll say const response equals await Axios dot get. And for this moment, I'm just going to console.log it because I like to see things are working before I go any further. Okay. That for a second. Okay, cool. So each one of them came back. We really just ran 4, but you know, because of how it works, it looks like we ran 8. 65, a snowy, and notice these came back in just any order. I couldn't control that. And if I wanted to, I would have to use like promise.all or promise.all settled. But this works enough for now. Yeah, this is fine for now. And then what do we want to do when it comes back? When it comes back, I want to update the inventory. So I'll say something like set inventory. I'll take whatever the inventory currently is and I'll spread it. Which, you know, initially it'll be the empty list, but every time I add something, there will be something in there now. So spread it. And then the next thing is, okay, we got these responses. I want just response.data. Cool. The next thing is going to be response.data. And because we're updating the inventory, it should refresh. And how about we just print the inventory at each step? Cool. Reload. So the inventory is interesting. It's empty, then it has one thing, then it overrode it with a different one thing. Okay, so I'm seeing that my method is not a smart method. So let me try doing this with promise.all. Let's try that out. So what I would actually do is something more like filmids.map, maybe, because each one of these things I want to return a promise. So filmids.map, what are we mapping it to? For each film ID, I want to, doesn't even need to be an async function. I'll just say, you know, for each film ID, I can even move it in here. For each film ID, return a promise. Okay, for each film ID, return a promise. And this is just going to be a list of promises. So I'm going to say const responses equals that. And then I can say promise.all for, well, I guess these are the requests. Promise.all requests. And what do I do in response to a promise.all request? This is, at this point, if I want to use async await, it's getting a little annoying. I would have to make a new function. So I'm just going to make a dot then underneath. And it's going to have responses, and I'm just going to assume none of them fail right now. And what do I do for the responses? I'm going to say something like const film data equals responses, of which there should be multiple of them, dot map. And for each response, map it to response.data. And so we should have a list of film data at this point, and then I could just say set inventory. I don't care what the initial thing was. I'm just going to set it to film data. I mean, maybe I did care what it was. Maybe there is something important in there. So I'm just going to say, right, inventory as it is, and then put everything in film data after it, which also needs to be spread because it is itself a list. Cool. Okay, so now does this work? We'll see. Reload. Again, reload. Am I not console.logging anything right now? I do want to at least console.log it to see if it worked. Okay, now it's working. Oh, and I see. But funnily enough, because of how React is doing things, I'm actually running everything twice, which is a little annoying. So I'm not going to mess with this spreading thing. Just we're always setting it to film data. We're overwriting whatever was already in inventory. And now it'll look normal. We have these 4 things in here. Cool. So we're basically out of time. But you can see how I've already demonstrated that I'm going to use useEffect and promises. And as a result, I have an inventory now. And even though, because what's in there, the data is not the same shape as it was before, everything's broken as a result, it wouldn't be too hard to make it work. So I would basically just like sort of what's the word? You can sort of like in a very step-by-step manner say like, okay, well, I'm doing this now, and homepage is passed in inventory first. Is it even working? Almost certainly not. And those errors would tell you things, but basically I'm going to look, okay, we got an inventory. Let's go in there. And, you know, we use the inventory at times where we're mapping it, and I expect it to have ID, title, image URL, copies available. But it doesn't have that. Instead, it has whatever's in here. But I'm pretty sure I can quickly make that work where I say like, okay, ID, does it have an ID? It has something called IMDb ID. And so even though we usually destructure things by giving them the name they already had, I believe I can do this where I say, I believe this works from mapping inventory ID and whatever the value of IMDb ID is, I'm gonna give it to this thing called ID. I think this will work. I'm just sort of renaming things. So title is called title in capital. Let's see if this works. Image URL is called poster. And I'm only doing it this way so that I don't have to rewrite what all these individual things are called. I'm just passing it the right data, and copies available is not a meaningful thing anymore. But just to keep it working, might as well say copies available is always going to be 4. Okay, save. It is hard to make things work in real time. Why is it complaining right now? Where's it trying to get? Maybe I just. Why is it even looking for that anymore? Does inventory item look for it? No. What changed? Does anyone have any idea what changed? Okay, it doesn't like that. Okay, maybe it's the other way around where I have to go like this. I know there's a way to do this. Let's try it out. Just going to remove that and give this a random number. Okay, let's try that now. I don't think I'm going to get this to work in time, and I don't want to eat in too much to your guys's lunch. Let's see. Okay, not bad. I mean, the fact that that works at all, pretty good. As you can see, the styling's not quite up. I'm not actually seeing 4 available. That doesn't seem to be working because of how I wrote it and the fact that that's not in that API. But still, we're getting a pretty good thing. I can click this, and it looks like there's more that needs to get updated. But yeah, so it's not weird for your app to break when you change what the data looks like. But yeah, that's hopefully a good enough demonstration. Might as well start wrapping up now. So you have Video Store Part 2 as a starting point from yesterday's demos and notes. A solution looking version is in today's demos and notes, Video Store Part 3. And as it has been lately, the assignment for today is to, now that you have useEffect, continue to build out Video Store to the best of your abilities using the OMDB API. At the top there, we say what features we're looking for, but really whatever app you're trying to make, just try and integrate working with an API, whatever that is, and you can really make any app you want. We just want you to play with this thing that you now have useEffect, and you can trigger it. And just a little note of warning here, which is basically the Pokey API is a great API because it doesn't really want you to set much up. GitHub's API is historically very easy to work with. There's some APIs, free APIs, usually with data that's not that useful or interesting and that you can only read from, not write to. There's lots of APIs like that you can search for and find something good and free, but be careful for this assignment about integrating with a real API like from Google or Facebook, because for security purposes, they usually require a lot of you have to do some pretty heavy-handed authentication stuff, And it's just not worth your time. Even once you're in the project phase, like you don't want to spend a week setting up, access to an API. And in the real world, you might have that week, and it's worth it if you need to like integrate with like Google Notes or something, but it's not worth it for learning. So that's my only word of warning. And yeah, we'll be back when you guys come back from lunch, and I'm going to speak to Nick, but I don't think we're doing pairs today, but I'll speak to Nick. He'll know for sure. Cool. That is it. If you guys have questions, I'll stick around for a bit. Otherwise, get lunch.